Have you ever wanted to build like an NFT with some custom logic in it? Just opened up a little terminal. And the template's pretty easy. It uses this tool called Cargo Generate. If you check out this little GitHub repo here, you will actually see some basic documentation on how to install Cargo Generate. We're going to call this project CW Piggy Bank. What we're going to do is we're going to actually create a custom NFT contract that implements the logic of a piggy bank. We're going to allow people to deposit funds into the piggy bank, and the only way to get them out is if you burn the NFT. Imagine if we're playing like a game where there's monsters and they battle each other, and if one monster kills the other, then they can get the funds out that are inside that monster. The files for this little piggy bank, we've just created in this one little command, which is cargo generate. We just created a whole new NFT project. The contract is actually just one little file, which is nice. We've got our cargo.toml file. And the cargo.toml file is like all the dependencies we're going to be using for building this smart contract. We've got a little README. It has a lot of the template stuff in it. We're actually going to clear all this out. I like to start by thinking about the functionality we're going to make. So we're going to start with this little README file. In terms of other things in this folder, obviously the source is in this lib.rs file. I'm going to walk you through everything involved in creating a custom NFT contract today. When I write a smart contract, I think it's always good to think about what is it trying to do at a high level. And oftentimes you can just do this as like an outline. So I think for CW721 Piggy Bank, first of all, it's a basic NFT contract, right? So it's going to implement everything in the CW721 standard, which is equivalent to the ERC721 standard if you're coming from Ethereum world. Secondly, it's going to allow people to deposit funds. We're going to implement a query to show how many funds are in the piggy bank. We're going to override the default burn method for this NFT to return the funds in the piggy bank. And then I think as a bonus, depending on how much time we have, it'd be cool if we could show a different token or a different image, the more money that's in the piggy bank. I think that would be a final thing to add. And this will be a nice little simple contract. And you can think of ways that you could take some of this code and make it a little bit more complicated for a game. The idea that like different individual NFTs can have money associated with them, and that like various things might happen with that money depending if that NFT is burned or if that NFT is like given some new ability or whatever. I think it's important to start really simple, but I think we're going to try to get at least this stuff done. But if we have time, let's try to make it so we're going to show a different image. So maybe like an example for this would be like, let's say these are regen NFTs. And if as you like, it's like trees. And as you store carbon credits and the trees just grow at the more money that's in them. And then the NFTs are backed by underlying value because you can always like burn it and get out whatever tokens are on the inside. I don't know, it's a dumb idea, but I think it's going to show, the main thing is I want to show you guys how to make a custom NFT project. I guess before I start, any questions? I guess to review, we just ran that cargo generate command, and now we have a whole NFT project, and we're basically ready to go right now. All right, I'm going to just keep going, but feel free to interrupt. Right, so this, and I hope the font is big enough for people. I can actually make it a little bit larger. So this was all generated with that cargo generate command we have. And there are a couple of different parts, okay? So we have a couple of different structs up here. We have a metadata extension, an execute extension, and a query extension. So I'm going to cover what each of those different parts are. When in that CW721 generate template, there's actually the option for a minimal template, but we went with this is the full template. I'm going to cover what each of these are. This is the metadata extension implements like on-chain metadata. So by default, like when you get, and this is true in Stargaze or even like some Terra NFT projects as well. When you get an NFT project, the only thing that's stored on chain is this thing called a token URI. The token URI is like basically just like a link to some off-chain JSON metadata that's usually stored on IPFS. This metadata extension can allow us to store some extra things on chain in on-chain metadata that we can also, for example, use like programmatically inside a game. This execute message extension is basically used to add extra functionality to the NFT contract. By default, the NFT contract has a bunch of execute messages in it. We can look at them real quick. So this is stuff you might be familiar with if you've worked with NFTs before. If not, just feel free to ask questions about it. So this is like the base CW721 like implementation. You have things like transfer NFT, send NFT, which is basically allows you to send it to a smart contract with a particular message. We have some approval stuff. We have mints. Everyone knows what minting is, yay. And we have burning, and that's like the basic NFT interface. Cool thing is with this code, we actually don't have to implement any of those send or transfer or anything like that. We just get all that for free. We can potentially override that, and we're going to override the burn method in a bit, but I just want to note that. So then query extension is like basically the same thing as execute extension, but for queries. So it allows us to implement some custom query messages. And we're going to think about what those are really quick, but I'm just going to do a really quick run through of this contract, and then we'll get started. This might be a little bit like tricky for some people, but I'm going to try to like explain what a lot of this syntax is. If you've not used Rust, there are some really great resources like the Rust book. I particularly like the YouTube channel Let's Get Rusty. It can provide a much better explanation for some of the syntax we're going to see today. But yeah, this is really the like where we're configuring everything. So we have this base CW721 contract. And this is a base type that takes a lot of generics. So as you can see, we're passing in the metadata extension, we're passing in the execute extension, we're passing in the query extension, and we're creating this CW721 contract type. We're also creating an execute message type, which takes the metadata extension and the execute extension. Everything in Rust is very type safe, so it's very strict in terms of its type system. And here we're doing the same thing with the query extension. But let's get to it. This is the actual contract implementation here just so far. So actually, this entire thing is the entire smart contract for an NFT contract. Pretty cool. So let's walk through the basic parts. CosmWasm works with this concept of like entry points, and there are about like I think 7 or 8 standardized entry points into a contract. Some of them are like a lot of them are related to IBC, but the most important ones you really need to know as a smart contract developer, the 3 most essential ones are the instantiate entry point. This is called when the smart contract is created. It sets the initial state of the smart contract. The other entry point that's like vital in every smart contract is the execute entry point. This is what you use to write to state. This is what you use to modify the state. These are the smart contract methods. This is where like shit actually gets done. And then finally, we have the query entry point, which is basically a read-only queries for smart contract state. And that's it. That's all, like basically a whole CosmWasm smart contract, instantiate, execute, query. So let's start with the instantiate first. This will just take a little second. We take each of these basically gets the same arguments. We have dependencies. We have the environment. Environment contains things like block height, things like that. We have info, which is info about the message. This contains information like the sender account, contains information on like gas paid and things like that. And then finally, we have the actual message, in which case this is an instantiate message for an NFT contract. So it takes a name, a symbol, and a minter who will be the address that is allowed to create and mint NFTs. And it returns just like a simple result type. So yeah, what's happening on instantiation is we set the little contract version. So there's actually some helper libraries. There are many different CosmWasm helper libraries, and perhaps at the end we can talk about some useful ones during Q&A time. But we're basically setting the contract version here. And then using this default type, this type that we created up here, which we got from the CW721 base library, and we passed in all our different extensions. Using that default type, we call the instantiate method on it. And that's it. It handles all the like basic NFT instantiation contract. So that gives us like a default implementation under the hood. This entry point here, execute. This is where we're going to implement our logic for this piggy bank. By default, we're just also passing things off to this default CW7 contract that we implemented above. But we're using a match expression in Rust. there's this beautiful match expression syntax. And if it's like we can override messages here. So we're actually probably going to do that here. So we're going to override the burn message for our piggy bank, because when we burn that NFT, we don't want to just burn it. We want to also pay out the money that's in the NFT. So we're going to implement that today. There's also this execute extension message here, which we're also going to implement today. So this is where we can implement a lot of our like extra functionality that we're going to define above. And then query message works the same way. It's also using a match expression. This little syntax here at the end is like a catch-all. So this like little underscore arrow is basically just only match this, and then for everything else, pass it off to the default query implementation. And there's a bunch of different NFT queries, like querying for the owner of an NFT or listing tokens by owners or whatever. The cool thing is that's all in the base contract. We don't have to implement any of that. And I'm happy to answer a lot more questions about that as we go. But yeah, I guess any questions so far before we start actually implementing this little piggy bank? Going once. I do like it if people are talking more. 10 Juno to the best question for this session. All right. So let's go back to our README. Oops. So we've already got the basic NFT contract. That's already done. Let's just make these little checklists. So that's done. Okay, we need to allow accounts to deposit. We should implement a little helper query to show how many funds are in the piggy bank. Probably this is not even really needed because every smart contract is also just an account. So for every account, it's really easy to use built-in Cosmos SDK stuff to query the balance. So maybe we don't even need to do this. We'll just leave it there for now. And then, yeah, basically, so we need to allow accounts to deposit funds, and then we need to override the burn method to pay out funds in the piggy bank. And then as a bonus, we'll show a different image if the money is in the piggy bank. And then I guess I think we're just going to kill this for now. Maybe we'll come up with some other functionality we want to add to this as we go along.
Can you basically add like every Juno native token, or is it just Juno that you can deposit there?
Oh, that's a good question. So when we say allow accounts to deposit funds, do we want to limit it? That's actually a really good question. Do we want to limit this to like a particular token, maybe like USDC or maybe Regen or maybe just Juno? Or do we want anyone to deposit anything? It's really up to us. So whatever people think would be more exciting. But yeah, let's get started. So I don't think we need any custom on-chain metadata just yet. We might in a bit, but let's get started with the execute message. We're just going to call it deposit. And it doesn't we're going to need to specify a token ID. So the token ID for the NFT. This should be an enum. Screwed it up. All right, there we go. Cool. This should also be an enum. All right, I'm still working on this template, and yeah. So enums in Rust are just like a value for this execute extension can be just one of any of this list of messages that we're going to eventually create for it. I think we really only need one right now, which is deposit, and it's going to take a token ID, and we'll go about implementing that right now, unless there's like other questions. And then the other thing we're going to have to do is override the custom burn method. Now, for the query extension, we can implement custom queries in a similar way, but we're just going to ignore that for now. So now that we've defined deposit in the execute extension, and remember, we're passing that into this default contract implementation, We're also passing that into this execute message. So I guess real quick to understand this part a little bit, this is actually using what are called like basically like generic types in Rust. So see how we have this enum here, which is the execute enum. And you've probably seen this if you've done a CosmWasm smart contract before, but do you see this little T and E here? These are generics. And if you scroll down here, we can actually see the generics being used in the messages down here. This allows you to create like a type that's like basically extensible. For example, we could just do like let's say we wanted to create an extensible config type. The syntax kind of looks like this, where you just have like your like struct type, and then you got like your little brackets there, and you pass in. You can also like label these, give them like a human readable name for generics. This is just a macro that provides all the serialization and deserialization stuff we need for CosmWasm. So it's a really handy way of making, like when you define a struct, you can just use CWSerd, and now the struct is ready for working in CosmWasm. But yeah, so we could then use this token type inside of the struct. But then when you actually use the struct, you have to be explicit about what the generic you're passing into this struct is. Let's Get Rusty has some really great videos on the Rust type system. I know that generics are maybe like a little bit complicated for some people, but you'll definitely encounter them in the wild. So it's good to learn about them. All right, so we're back here. We just defined our execute extension up here. We've got now this deposit method. Okay, cool. Now let's actually wire it up. So what's happening here is, again, when execute message is called, it's going to provide an execute message type, which is going to be one of a particular of an enum. So this match statement is basically looking at that message, and if it's execute message burn, pass it off to this function. This is kind of like a handler pattern. If it's execute message extension, we're going to match what message it is in the extension. And if it's the deposit message, we're going to pass that also off to a function. And finally, if it's not either extension or burn, and we could also override additional things here, then pass it off to the default NFT implementation. Does that make sense for people? Okay, I'm seeing some thumbs up, so we're gonna keep going. Exciting times. So we could actually, sometimes for a simple contract like this, I like to do this stuff just in line because, you know, it might be a little bit nicer, and there's only like a few functions here. You could also define a function, like, so for example, but you don't have to do that. I'm actually just going to do it like inline here. Or fuck it. Let's just define the function. So we're going to define an execute deposit function. It's going to take our dependencies, and these are going to be the mutable dependencies. So the dependencies are basically like how we write to the blockchain state, like basically like our APIs for querying the blockchain state. That's all in dependencies. We're going to pass in the environment. I'm not sure we're actually going to use it, but why not? We're definitely going to pass it in the message info because we need to. That message info also has things like information on funds and stuff. So if we go look at this, we can see the sender, and we can also see the funds that were sent with the message. So we're definitely gonna need that. And then finally, we're gonna pass in the token ID, which is a string. And this is going to return, let me just make this one screen. It's gonna return a result. So results are used everywhere in Rust, and you just learn to love. It's like one of the default types. Result returns either an OK value or an error value. The OK value is going to be a response. So this is going to return a valid CosmWasm response if everything is good, or it's going to return a contract error. Cool. And now that's our execute deposit function. So let's wire it up. So we just pass it into our little handler here. Cool. And then we're actually going to just do the same thing right now with burn. I'm getting a lot of the compiler screaming at me, but yeah, it's just part of it. I probably made a silly mistake. I did make a silly mistake. Oh, I see what happened. There we go. I really suggest using something like VS Code when you're writing Rust because it really helps you a lot with like auto completion, and all these little squiggly lines tell you a lot of useful stuff. Makes your life easier. All right, so now we've wired up our contract, at least at the minimum kind of things that we need. So we have execute burn, or we have our burn override, and we have our deposit extension. But we have our first problem. I guess I'll just describe what it is, and then maybe I'll ask the crowd for some suggestions. So the problem is there's multiple tokens in an NFT contract. Like an NFT contract might have 8,000 NFTs, like Bad Kids, for example. Like the Bad Kids NFT contract that has 9,999 NFTs. We need to actually, when we deposit the funds, we need to keep track of which token has which amount of funds. This is gonna be fun. Okay, let's go. And for that, we're actually going to need some state. So we're actually going to come back here, and we are going to. So this is our contract root. We're going to look at our cargo.toml file, and we're missing a nice little library here. And that library is CW Storage Plus. CW Storage Plus is an amazing library. Let me just grab the link for it real quick, and I'll throw it in the Dev Lounge chat. Also, feel free to like put questions in the chat. But that's the link to the library we're going to use. CW Storage Plus has a bunch of helpers on things like working with blockchain storage. So particularly working with items, or in our case, we're going to create a map. Maps are great. Let me just build. So when you add a new library to your cargo.toml, you can then use it in your code. For example, we can go in here, and to use that library, we just use the use keyword, and we just select the module. And there's a lot of great stuff in this library, but we're actually just going to use the map type. Maps are really useful. When you make a map, you can create a relationship between two things. So for example, in our case, we are going to, this file is going to probably get a little bit big, and something we might want to do later on is break it up into multiple files. But we're going to create a map for storing NFT balances. We're just going to call it balances. Unless someone thinks of a better name, we're calling it balances. And this is going to be the map type. And it's going to take a string. Actually, let's make this a pointer to a string. And it's going to map that to we're going to change this later, but for right now, it's going to map that to a single number. I think to start, we're just going to maybe assume that there's only one type of token that people are feeding this NFT with. And then we can come back and refactor this. In fact, we'll even leave ourselves a little note.
Can we also add, we deposit different tokens, let's say Juno and USDC. We also make a query to see the USDC balance of the total state, of the total deposit.
Ooh, that's a great idea. Yeah, actually, you're right. In fact, I didn't realize it, but we actually do need to create the balance query. And the reason is because all the funds for all the NFTs in this contract are actually held in the contract. So if you just went on MintScan and you put in the smart contract address, it would show you the total balance across all the NFTs in this like piggy bank contract, if that makes sense. So we actually do need to implement like a balance query for the tokens. And then what else did you just suggest there? What else did you want to add?
Basically to see the USD balance for every NFT, like the deposit. If I add 5 Juno, for example, and $5, to see the total USD amount which is deposited in it.
Okay, that's a good to-do feature for soon. And then there's also a question of, okay, so we could do that with an Oracle, or we could just also do that on like the front end. Let's just assume we would do that on the front end for now, but we can talk about how to implement that after we get a little farther with some of the basic functionality. And who knows, maybe we'll do this again like next week and try to get a little bit farther in like implementing more advanced functionality. Oh my gosh. Live coding is like really hard because I have to like talk about stuff and explain it while actually doing it. And I'm still practicing, guys. Give me a break. So yeah, I like to add some comments. So this will, in fact, I like tend to add even more comments than are really needed. So use to deposit funds in a particular NFT. Also, if you want to play along, feel free to run that cargo generate command I put in the dev lounge and code along. Maybe you'll actually be able to finish it quicker than I can. I wouldn't be surprised because. All right, so now we've got this new piece of state, which is a map. It's called balances. It takes a string, which is the token ID, and it returns the amount that is deposited on a particular piggy bank NFT. In the future, we're going to actually change this uint128, but we're just going to leave it as is now so we can just move quickly and cover a lot of ground. All right, so now I think we're ready to execute deposit. Though immediately we get to another question is, should only the owner of the NFT be allowed to deposit funds? I'm going to say no, because if someone puts money in your NFT piggy bank, that's great. And why limit it to just the owner? And it's less work. But we could easily check if the owner is the same as the sender and then throw an error if not. But I think for now, we're just going to make sure that we can make as much money as possible with this NFT piggy bank. How's everyone's day going? I'm tired. But all right, let's just do it. Okay, so first things first, we want to make sure that funds are sent. Sometimes I like to actually just write myself like little to-dos. We want to throw an error if the token doesn't exist. Like we don't want people funding a token that doesn't exist. All right, what else do we want to do? We want to check that we actually sent funds. We want to throw an error if token doesn't exist.
What about if it was already burned, right?
Then the token wouldn't exist. That's a great question, but yeah. So
Is it removed from the state?
Yeah.
When it's burned? Okay.
Yeah,
I didn't know that.
Yeah, there's no going back once you burn.
Nice.
So I think we're gonna want, so we want to check that funds were actually sent. We want to error if the token doesn't exist. We want to save the balance in that balances map that we just created.
Do you also want to
No,
show?
actually, we want to update balance and balances map, because what if someone already deposited, right? We want to make sure that we're adding to the balance and not just like overwriting it. So I'm going to change that to update. What else? Also, I think oftentimes when we write smart contracts, we oftentimes want to like just dive into code immediately. A lot of times I think it's really helpful to, before you start writing any Rust code, just thinking about, okay, what do I want to check? I want to check that this is only sent by a certain person, or I want to make sure that like the token exists. Or sometimes it's like a lot easier to just write yourself like a little list of to-dos, or at least I like to do it this way. There's no right answer, but write yourself a list of to-dos and like making sure that you're checking all the things that you should be checking before you actually get into writing the code. Yeah, I'll ask again, is there anything else we want to like check or do when we're like making this deposit? To be honest, I can't really think of anything. So maybe we'll get back to that. So on the burn side, let's do the same thing. What are we going to want to do on the burn? Probably something we want to check. How about ownership? I don't want someone else to be able to burn my NFT, right? That would be bad, right? Yeah, we're gonna check ownership, which I think is actually already handled by the default implementation, but I figured we'd bring it up anyway. Also, each one of these things are like good things that we're gonna want to test later. Like for example, we're gonna want to write a test that makes sure someone can't burn an NFT they don't actually own. That would be bad, right? That would kill the NFT piggy bank project. It had so much potential.
If it was staked,
You wouldn't be able to burn it if it was staked. If it was staked in a DAO.
should that be something that we need to check?
The owner would be the staking contract. So I think we wouldn't have to worry about that right now. They would have to unstake their token and then burn it in order to break the piggy bank.
Yeah, cool. So that's the logic I was looking for. Is there's a check that says that you're able to burn it, and that would be the owner being you, not the staking contract.
Yeah. What else do we have to do here? We need to pass it off to the default burn implementation. I'll show how to do that. There's one more thing we're going to want to do.
Transfer the tokens.
Yeah,
Check the balance.
we want to pay out the rewards. Yes, let's pay out the piggy bank. Let's go. And we may want to think of perhaps there's some checks we should potentially do related to this, but we can think of those later. All right, to me, this seems like a pretty good little game plan. And so I think we're ready. I'm actually going to switch screens to my browser real quick, and I want to show you guys some cool libraries that we're probably going to be using in implementing some of this contract. So let me just change windows real quick. Can you guys see my browser window? All right, cool. So I want to point you out to docs.rs. This site is amazing, and it has all the default like documentation for every CosmWasm library you possibly want to use. So for example, we can look at something like, I don't know, the CosmWasm standard library. And here it is. And now we have everything that is in the CosmWasm standard library. everything from helper functions to enums. Oh, here's the bank message. We're probably going to want to use this because we're going to use this to send funds. All right, cool. And it's just got like beautiful auto-generated documentation for basically every Rust CosmWasm library. I think a lot of people are like, where's the documentation? Where's the documentation? There is documentation and it's on docs.rs and it's just auto-generated. And that's one of the great things about Rust is it has like beautiful, like just default auto-generated like documentation for every library. And that's true for even things like one of the libraries we're probably going to use is CWUtils. Oh my gosh, I didn't want that. What's this? Oh my gosh. All right. Yeah, so CWUtils has a bunch of nice little helper functions. So again, we can see every little like function. Like here's a must pay function. And you can see the type signature for it. And if they wrote comments, you can see what the comments are. So a little helpful tool for folks. Just want to let you know about docs.rs. It's your friend. Every time there is a like CosmWasm library that you're not familiar with, plug it into docs.rs and you'll probably get some really good information about it. Back to our code. I'm just going to actually check our dependencies real quick. And do we have CWUtils? No, we don't. So let's add that here. And you can just pass in the version number. On some libraries, there's more complicated options, but Let's Get Rusty has another great video on managing Rust dependencies and Rust projects. Really great to learn all that stuff. There's actually tons of great documentation about learning Rust. And once you know how to work with Rust, it's really easy to work with CosmWasm. Let's just build it really quick so that we can get some smart auto completion. All right, great. All right, so in terms of, we want to check that there are actually funds. And so for that, we'll probably like change this later, but we're going to use a function called must pay. Now, must pay, if we look at it, it basically checks the message and makes sure that only one denom is sent. So we're going to hard code this for now, but we'll change it later so we're must pay is going to take this message info, which remember has the sender and the funds. And then for the denom, we're just going to make it Juno for now. And if we look at the implementation for this as well, you can see that it also requires exactly one coin is sent, which is good for right now. Because remember, in our state, we are basically assuming that every token has basically one balance associated with it. We have a to-do where we're gonna like refactor to support multiple tokens as deposits, but that's gonna come later. So we're just gonna do the simple thing and just make sure that this message only contains Juno. And it will err if Juno is not there. So it'll err if no funds were sent, and it will err if USDC or some other coin was sent. I'm going to also add our little to-do message here. Sometimes if there's a factor and it happens, I like to-do messages, and I like to put them everywhere that touches on the code. So then it's really easy when we go back and refactor it. We'll be like, oh, we have to change this part. We have to change this part. We have to change this part. We're going to need to check if the token doesn't exist, but how do we get access to the tokens that are living in that base contract? So there's actually two ways we could check if the token doesn't exist. Like option one is we could do a query, which is weird in this case to query our smart contract, because this is useful if you wanted to like query like a separate smart contract. So say the contract we were writing is different from the contract we're trying to query, then I think a query would make more sense. Option two is we want to just read from state. So because this contract is the same as the information we're looking for. We're just gonna read the token state directly. Let's do that. I'm gonna make a little base variable, and you notice how up here we're doing this like little CW721 default thing. We're gonna do that down here. Great. So what is this CW721 contract? It's this guy right here. This is the base contract, and it has inside of it all of the base logic and state. So if we look at that, it has a lot of stuff. It has the count of tokens. It has all the state for all the different tokens in there. It has a bunch of stuff. We're just going to assign it to a little variable here. We're going to call it base. And then we can do base tokens. So CW storage has a little helper method called has. So this will error if the token ID doesn't exist. I don't think that's needed.
Short question. Will there be also an error if you try to burn this NFT without having anything stored into the piggy bank? Or can we like a warning for that?
Yes, there will be an error. Oh, actually, so you want to make an error if there's just nothing stored in the piggy bank.
Exactly.
We could do that. Can you think of any drawbacks for that?
I don't know.
What if someone sent me a spam NFT? They sent me like a really big picture of like, Don Kryptonium, and I was like, what the fuck is this? I don't want this in my wallet, and I just wanted to burn it. And then it's haha, you can't burn it unless you like pay like the deposit or whatever. That would not be super great, but maybe this will give people fun ideas for stuff. Yeah, we could do that. We'll make a question mark. But yeah, it's possible. So we could check if this has a balance and then throw an error if it doesn't have a balance. So let's actually just, I guess this is a good question. What's the difference between has and load? Has is like going to be like a little bit more gas efficient because we're not actually loading the value, that we're just checking that it exists. So I think we're going to use has here, that we could also do it with load. The reason we would do it with load is if we wanted to actually use the value of the token there. But I don't think we do at the moment. Maybe we want to do it later. Yeah, let's actually just use load here. So this load, you see this question mark at the end? We actually talked about this last time. What this question mark does is this load function, if we look at it, it returns a result. So results either have an OK value or they have an error value. What this question mark does is it unwraps that and returns the OK value if everything's good, or it throws a contract error if something's gone badly. So this is actually what we need for our check right now. So we're going to just reword this to.
Hello.
Get ready for your omakase.
Hey, what's up? How's it going?
Whoops.
Sorry.
So yeah, this is good enough now to check that the token exists. Now, if we want it to be like super gas efficient here, we might use has versus load, but we've got this bonus to do that we're hopefully going to get to later. So we're going to want to load the token for that. But yeah. Okay, so now we want to update the balance in the map. So to do that, we're just going to do balances. All right, so there's two ways we can do this, and I don't think either one is like right or wrong, or I'll show you both ways. So we can load the existing balance for a token. Now, you might think to do it like this, but this won't work. Does anyone know why this won't work? Why would this not work? What if the balance doesn't exist? What if no one's ever deposited on this token before? Then you can't load it. So we would actually need to do a mayload here. And what mayload will do is if this, basically mayload would return an option type rather than a result. So we look at that, it returns an option, yay. And so what that means is like this existing will be either some value or none value. And we're going to do different things depending on its value. So we're going to do that with a match statement. So if there's some oops. Mm-hmm. I forgot to do something up here. So this must pay function returns, so it does the check. It checks to make sure only one coin is sent. If the coin is not the right denom, it throws an error. Otherwise, it returns the amount that of the coin that was sent. So we're actually going to make a variable amount up here, and we're going to use that right now. So if there is an existing balance, we are going to save balances, and we're going to take the existing balance, which we're passing in right here with this sum argument, and we're going to take the balance and we're going to just add amount to it. And if there is none, we are going to initialize it. So we're going to do balances dot save. Oh, so now it's complaining at me. Rust is very strict on types. So anytime you have a match statement, you have to make sure that it returns. All right, we'll fix that in a bit. High level, this is okay, and we'll debug this together.
Just question if I can, feel free to tell me later. Must pay and that sort of, is this safe from flash loans? Because I noticed you like added to the balance. Would that be, is there an opportunity there for flash loans? Like change the balance before anything happens?
Flash loans, potentially. So the way flash loans work, if you're not familiar, is that you have to, basically you can borrow a very large amount of money with the caveat that you have to pay it back in the same transaction that you borrowed it. So I'm not sure how vulnerable piggy bank NFTs would be to flash loans, because you'd have to take the flash loan, deposit money into the piggy bank, and then burn it. And there'd probably be no profit in doing so, but maybe there would. Maybe someone will figure out some crazy idea. Anyway, this is one. I know there's some errors here. Oh, I think it wants to. All right, we're gonna do some debugging later, but I just want to get on with the tutorial but we'll debug this and that will be fun. There's actually another way to do this. So this is one pattern, and if someone wants to figure out what's wrong with that code, you can get 10 Juno, as long as you help explain it to other people what's wrong with it. Another way we could do this is instead of loading the balance and then saving over it, we could just actually use update. So the update takes our dependencies again, storage, yep. It takes our token ID. And then it takes what's called a closure. This is going to be our balance.
Hi. For the match statement, I think the error was it's expecting like a tuple for the error, and you only gave it the option, like contract error.
Amazing. Paste working code in the chat, and then we'll get that fixed. Yay, we're doing it all together, guys. We're doing it all together. All right, so this is another way we could do it, where it's like we just do this balance, and then we basically update it inside. So the balance type is an option. The reason that this is an option is because remember, the balance may or may not exist, depending if we've made a deposit for. So here we could do something like, there's a bunch of different things we could do here. We could do unwrap or default, which I believe the default is 0. We'd have to like double check that and write, this is why you write tests for everything. But we could do that, unwrap or default, and then we'll just add our amount here. So this is maybe a little bit more confusing to some people, but it's the same as this guy right here. Does that make sense? But yeah, so basically the update functions, they take the storage, they take whatever the key is for the map, and then they take a closure. And the closure in our case is returning a standard result. And this balance type is an option. So here we're doing unwrap or defaults. Another thing we could do is we could do actually our match statement with the balance here, and then handle both the cases like we did above here. So if there's a balance that exists or if not, yeah. Okay, so now this is working great. So we are going to return, we did everything in our notes, guys. So let's return the response. So we have our response. We'll just make a nice default response. We can add attributes to that response. So for example, we could just say, this is a deposit action. These attributes get included with the on-chain transactions. They're very helpful for use with like indexers and stuff like that. So I think they're quite useful, especially if you ever think about building a protocol where you might use an index or something like that with it. So now we've just got a default to finish this off. And this is like basically, obviously we're going to go back and refactor. But this is basically a working MVP deposit function. Oh wait, no, there's a squiggly line. Oh yeah. Okay, yes. So this is actually a really great thing to cover. So what's going on with this squiggly line? This is sad. And it's saying that it can't convert the error to this contract error type. Rust is very strict in terms of types. And as you can see, this is returning a result of uint128, and then it's also returning a payment error. We need to actually extend our contract errors so that we can fix that. Or we could also just do a hacky thing, which I'll show you the hacky way. So we could just do map error. There's a standard CosmWasm error thing, and there's a generic error. We'll just say invalid deposit.
Yes, thanks. Right now.
Can you speak a little bit louder? It's a little bit hard to hear you. Was that a question?
I don't think it was.
Oh,
I think it was just like unmuted for a while.
I think we should just do it the normal way. Right. To do fix error types. This will be a good thing to do at the end because I feel like this is probably like the trickiest part of being a Rust programmer is like learning to work with the type system. It's even trickier when you have a whole bunch of people watching you. I think my editor might be a little slow. But yeah, so the reason, just to explain like this mysterious error for what was happening is we got this must pay function and it's returning a result, and that result is a payment error. But this is got a little contract error here. The types are different, and so it's not happy about it. It's not happy at all. One of the great things about Rust, though, is it'll tell you like really great suggestions for your code. So as you can see, I did not use the result here. So this creates a result. And if I add a question mark here, that will remove the warning. And moreover, if this errors for whatever reason, this question mark will mean that error gets returned and that the transaction will fail. Rust, it's frustrating, but it's usually making you do the right thing. This is not the right thing, so we will fix this later, but good to move on a bit to our burn implementation. I'm just going to remove this for now. So whoever brought up how to fix it, send me a friend request and DM me your Juno address. That was great. So perhaps, fuck it, we'll have more prizes. Like, just
I just looked at the docs and it looked like it was a STD result and not just the result, which might be what the match is looking at right now. What you put in the match.
Oh yeah, it was probably something stupid like that. It's the update function is like equivalent to what we just did, and it's a little bit like more compact. So I act the update functions, but either way is valid. Like you can do the load and then save over pattern, or you can do like the update pattern. It's not whichever you pick or whichever you feel most comfortable with. Maybe update is a little bit more gas efficient. I wish Reese or Zeke was here to let me know, but a lot of times it won't really matter too much. So check ownership. This is already handled in the default implementations. We'll just have a to-do to write a test for it later. All right, so we just called burn. The check for the ownership is going to handle be handled in the default implementation. Let's just do the default implementation right now. So we have our base contract and we have our default. And as you can see here, we have all the different things that we can do. We're going to call execute. We're going to pass in all the other stuff, and we're just going to do our execute message. Burn, baby, burn. So what do we have to do to pay out the piggy bank? Anyone have an idea?
Burn the NFT and verified ownership.
This is going to burn. So this is the default NFT contract implementation, and it's going to execute this burn message and do the verification for us.
You need to determine how much to send and who to send it to.
Yes, great. That's what we got to do. So first thing we're going to do is let's do the same thing we did down here. So we set the base contract. And I go down here and redo this. And we're going to load the token. So this will error if the token doesn't load. We could check the owner of the token here. So actually, I think this is already handled, but I'm just going to show how to do it because it might be useful. It might be useful to you in another thing you're just doing for your game. So we just loaded the NFT token here. It's not really needed, but for example, if info.sender not equal token dot owner, we're going to return an error. So this is, oh, too much JavaScript lately. So yeah, this is basically just like doing that check. Again, this is probably not needed, but this is how you do it. If you wanted to make this look a little bit less messy, you could actually just import this ownership error directly rather than having to have this like unnecessary kind of thing here. But oh, I think what we really want to do is we want to load the balances. Again, this will error if the token doesn't have a balance, which is like we talked about earlier. If we didn't want this to error, if the token didn't have balance, we would use mayload instead, which would return an option, and then we would do something different depending on if the token had a balance. Actually, let's just do that. So we're going to just do may load. So you can use match statements for working with option types, but there's also, let's say you only want to do something if you actually care about the value. There's also the if let syntax, which is maybe a little bit weird for some folks. So if let some balance. And now we can use the unwrapped balance in here. So we could do something with it. I'm actually gonna do the match statement though. So let's like match our balance. All right, so now we actually need to elect a bank message. I'm just gonna type it out and then we're gonna walk through what the fuck is going on here. Right, it's complaining that this is not a string, so we're gonna make that a string.
The balance value is a tuple, so you could do like comma underscore
Oh, it's
to disregard it. Or maybe not. I'm thinking F sharp, which is similar.
Let's try compiling it. Sometimes when you like your code editor will give you like certain things. 1, 2. Okay, so the error there, which was really confusing, is it said it expected enum result, and it's because I forgot to unwrap this may load here. So may load returns a result with an option inside of it, and I had forgotten to put the little like question mark on the end that unwraps it. So balance was actually a result, and it was like, hey, what's up? This expression has the type result option. So it was right. And now what's wrong with this guy? Mismatched types. Again, sometimes your editor will not give you the full Rust error. Ah, yes. So this amount, if we look at the bank message send, the amount here is a vector of coin types. So we have to do a little work here. live debugging only on, you know. And if there is a balance, we construct a bank send message with the sender as the recipient, and we send them Juno and whatever the balance of that particular NFT was. And if not, we do nothing. But in order to actually, we have to add this message to the response. So we're going to actually do that now. We're going to do add messages, which takes a list of Cosmos messages, and that's that. That's execute burn. We just did it, guys. Hooray. It takes a while for my editor to catch up. And let's just build it. Okay, everything built correctly. This is like a sort of working contract. So I guess to summarize like real quick, and then maybe let's do we'll do a quick summary. Then I'll take some questions, and then let's maybe do some refactors on this if people still have the energy. So real quick, we've got, just starting from the beginning, we configured an execute extension, which is deposit. We then wired up that deposit extension to an actual handler function, which is execute deposit. We also overrode the default burn implementation for NFTs. In the deposit function, when someone can only, in this case, send you Juno. We still have to fix this error. Maybe we can do that after this. We check that the token exists. We update balances for that token, whatever people paid. People can deposit as much as they want in. When people are ready to break their piggy bank open, they execute a burn method that basically loads the NFT to see if there's any deposits. If there are deposits, it creates a bank send message that sends the funds to the recipient, which in this case is also the owner of the NFT. We then execute the default burn message on the base NFT, and that handles checking our ownership. We can work on writing a test for that later. And then finally, we add our messages to the response so that when this is executed, this bank send message will also be executed. And that's like a basic NFT, like kind of piggy bank contract. So if we go back to our README, we got this. We probably want to refactor to support multiple types of tokens. Oh, we have to implement our token balances query. That'll take 2 seconds. Let's just do that real quick. So just like we did with the execute extension, we're going to do the same thing with the query extension. We've got like our little balance guy over here, and we're just going to wire that up right now, and then we'll take some more questions and finish it up. So over here, this is an extension. So we're going to do our query extension. Now, queries are actually usually, if you notice here, they're returning a standard result and they're returning binary. So we're actually going to do that. There's a really great helper function in the CosmWasm standard library called toBinary, and we're going to use that now. And we are just going to load our balances. I'm going to try to do this all in line. Okay, cool, sweet. Now we just implemented our balance query. That's just going to return the number basically. We could probably, if we were really ambitious, we could implement like a balance response type that could be a little bit more complicated, but You could always refactor this later. I'm going to push this on GitHub somewhere so that maybe we can also continue to work on it. If you guys want to like try to like make some PRs, maybe we can like actually turn this into the beginning of some crazy kind of game. I want this like ultimate fighter or like last man standing game where we like just have monsters that fight each other, but you have to put money on the monsters, like the monster you think is going to win. And the last monster standing has eaten all the other monsters and then can be burned to claim all the prizes or something. Could be fun. All right, I guess questions before we might want to finish up some of the last outstanding bits of work.
Hey, I don't really have questions, but I just wanted to say that you did great. Yeah, this is not easy even for experienced developers. Yeah, to do live code sessions. I don't know any developer that likes to do it, and it's easy. So it is great. One more thing, like
without Googling shit, like it's
it's I don't like it, so I don't know anyone who likes it. So it's never easy, yeah. So, but you did a great job, yeah. Just one thing. So I think it was. Sorry.
No, go ahead.
Yeah, Rarma, something like that, was mentioning like the flash loans, and I don't think like in the current implementation it is vulnerable to flash loans. But I was trying to think like how we could make it like vulnerable if we wanted to, and so if we take as an example that, let's say that if our piggy bank would have $100,000, for example, or 100,000 Juno, we would allow to mint a new like super rare token, right? A super rare NFT, next row one. Then it would be exploitable, right? Because we would be able to deposit, to burn, and to collect the new one. And give back the flash loan again.
It could be exploitable if when you minted the NFT, you could burn the old one and get back the tokens.
Yeah, exactly. Yeah. So
then we could make it exploitable because then they could get the NFT and the tokens. But if we made it so that you had to burn the new NFT to get back the tokens, they would have minted the new NFT and then burned it. It wouldn't be super useful. But yeah, it's good to learn about flash loans, especially if you're doing DeFi stuff. I feel like DeFi stuff can also be vulnerable. It's good things to be aware of.
Yeah.
Yeah, this is a basic piggy bank implementation. It's a little bit limited. Some kind of maybe future work we would want to do is maybe we customize our instantiate message to also include the reserve tokens for the piggy bank. We already talked about refactoring this balance to support multiple tokens as deposits. So for example, we could do that by just making this a vec of the coin type. And that would work. If we did this, we would also then have to update this code, and we would also have to update this code. So making this a vec would be, we would have to unpack the balances, and then, yeah, that could be a little bit tricky, but it's not rocket science. So the amount, we would have to have a different check here. We would just basically check to make sure that we would do a check like this, where it'd be like, make sure you sent some funds to this token. We don't care what they are, but we would return an error if they didn't send any funds to the tokens, if that makes sense. And then as balances would now be a vec of coins, probably rename this. And we wouldn't be able to do this like simple thing anymore. We'd actually have to, this is where we could get into performance things right now, but we'd have to like do a map of balances. Yeah, this would be fun, but yeah, we'd basically, and loops are terrible, but sometimes they're not too bad if you have 100 items. But imagine if someone sent a message with 1,000 tokens in it, that would probably run out of gas. So you should always be mindful of that stuff. Every time like a loop or like a map or whatever, you should be like thinking about like limitations of that. It's fine if there's someone might send 2 tokens at a time, or 3 or 4 or 5, or even 10 or 20 is probably fine. But if someone sent 1,000 tokens, the contract would probably run out of gas. But probably less relevant for this case. But yeah. So that's a refactor we could do. We're just not going to do that one right now, because I think an even more fun thing to talk about would be how we could make the, there we go. I think it'd be even more fun to talk about how we might make the tokens return like a different image if the amount was over a certain amount. Does that make sense? So let's say this is where the metadata extension would be really helpful. So we might do something like, we might choose to make this optional, but so we might have additional token URIs. We might extend so I guess a question for you guys, if we were going to implement, let's just use the example of the trees. Let's say we want to make regenerative tree NFTs. And in order to make your tree, you mint your tree and it starts out as a seedling. And in order to make your tree grow, you have to feed it like regen tokens or carbon credit tokens. In essence, getting people to lock up carbon tokens to make their like NFT trees grow. What sort of math would we use? And there's many different options. I don't think there's a right answer here, but if you're going to pick like some basic math to determine when to show a different picture, how would you go about doing it? One of the things we could do is just maybe even instead of just having a vec of additional token URIs, like we could just do this like in stages. Maybe there's 3 stages. Stage 1 token URI. And then you might have stage 2, stage 3. This is not necessarily the best implementation, but just highlighting how something like this is possible. And then we could modify the instantiate message to make all the parameters around this a lot more customizable, or similar to how we did with deposits earlier, where we just hard coded it to Juno, we can actually do the same thing. So when people deposit, we could do, this is actually, we'd probably want to load the balances earlier. This is where we might have actually, the original pattern we did, we might have, if we were actually implementing this, we might have gone back to that pattern. I already deleted it though, but. So we'd like load the balances, we would do that match statement. So it's basically just checking if the amount is greater than 10 Juno, we'd probably we could just update the base token URI. I'm just like spitballing this out, but next time I might actually like plan a tutorial more rather than just winging it. But I think this is fun. And then I think it's important for people to understand that even people doing this a long time are oftentimes confused, and we're all just figuring it out together. But it's all great to hang out with you guys and can you guys still hear me? I just accidentally like turned off my computer. Okay, great. Sweet. So yeah, we could update our state here. So like let token equals base tokens load. And here we could make this a mutable variable. So we could be like, and then we could just be like, so what do we just do here? If the balances are above 10 Juno, we load the stage 1 token URI and we override with the existing, or maybe we'll make this stage 2. Great. So we're actually overriding the default token URI, and let's save it. We could also do this with update as well, but I already started writing it like this, so we're just going to do it live. So complaining about that. Oh, this is a great little error. You see this error here? Let's run it in the cargo build. Value partially moved. Rust is very strict about memory management. And so I defined this token and I used it both here and I also used it here. And it's complaining that I moved a piece of memory without explicitly saying what should happen with it. Rust is very strict when it comes to memory usage. An easy way we can get rid of this error is to actually clone the variable. So I've got this variable here, and it's complaining that I moved that variable to 2 locations. So if I clone it with this like little clone macro, that'll make the error go away. And if we go back and build, voila. So if you come across that, actually, Rust, Let's Get Rusty has an amazing video on the Rust borrow checker, which is what we just experienced there. This is what keeps Rust very memory safe, is it makes sure that you can't create memory leaks and stuff through its kind of like borrow checker system. If you come across something like that, a really easy way, there's many different ways you could refactor your code as well, but also using this clone here is like a really simple way to get around some of those memory errors. But yeah, now our contract is compiling and we implemented a new feature, albeit in a very hacky way. So when we deposit tokens into this piggy bank NFT, at a certain extent, if the balance gets over 10 Juno, then we show the second token URI. So this is and we could probably definitely figure out a much better data structure for this, but just to show you like the general idea is like, if you want to create like a more dynamic NFT where like as something is happening maybe in your game, as that NFT is getting more and more like money associated with it, it's also changing its appearance. Or another thing is like maybe we'd also do like if this was a game, you could also use your metadata extension, which is all the on-chain attributes. You might have something like await, which could be like just a number. Maybe you have something like power. You can think about your in-game attributes or whatever. Or maybe you have something like luck. You got all your different attributes, each with their own like value to them. And you can build like more like similar logic when you deposit. If things are over a certain amount, like we might give this player or this NFT like better stats overall. That would be like actually on chain, and that other contracts could interact with them. One of the things I like about on chain metadata is that you can actually use it like programmatically. So you can write a smart contract that uses, for example, the weight of that NFT in like determining something that might happen in your game. Token URIs are really great for like images and things that are like too big to like fit on chain. But like the core data that's like actually used to determine like maybe a financial outcome, like again, if this is like a fighting game, like you want some of that like more important like metadata to be on chain so that you can use it in smart contracts. But yeah, I'm going to pause there. I think it'd be really great to do another one of these video calls really soon, hopefully with an even better streaming setup. And I think if people want, we can keep building out. Next time we can keep building out this NFT contract. We could probably do some refactors on it, and we could start testing it too, because that's something we didn't get to cover today. Is okay, so we got a working NFT contract. It compiles, which is great. Note, it's like still has a couple of warnings here. These are not necessarily that important, but we can fix them real easy. This is an unused import. We just get rid of that. And the other one is complaining also about a not unused variable. If you don't use a variable and you don't want to get the warning about it, you just put it like an underscore in front of it. And now when we build, we have no warnings. Perfectly clean, awesome smart contract. But yeah, next time we're going to get into testing. But I hope this showed you like how you can quite easily start making your own custom NFT contract. And yeah, we'll keep working on making things as easy as possible and learning together. And yeah, I think this is a fun example. Maybe we should maybe the thing to do is we'll just like turn this into a little series, and like once a week we just meet up here and we try to like eventually turn this into a little game. I think that'd be a lot of fun. Next time, I think I definitely want to like work on refactoring some things, and then also just writing some basic tests. Writing tests is super important in smart contracts, and there's lots of great tools to write tests with. So we can work on that a little bit next time. And then, yeah, keep thinking about different features you might want to add to this simple contract that we're coming up with.
Hey, Jack.
Yes.
Sorry, we still need to actually implement the deposit, right, in the balance. So maybe it's a good challenge for the next time. If people want to get the repo, you'll push it to GitHub, right?
Yeah, I'll push it to GitHub.
Yeah.
I'll share that. And then if people also want to like, we have a lot of to-dos in here. If you want to, I'll tell you what, if you make a good PR, get you some Juno as well. So learn some Juno, learn CosmWasm, hang out with cool kids. Yeah, I'll try to push this. We do have the deposit here, but I really think we want to make this support multiple different types of tokens rather than just hard coding it here to use Juno. Or at the very least, we should let people configure what type of token they want to accept.
Yeah, sure. I was mentioning like the actual update of the balance state. Did you know, like the new balance?
That's here.
Because we took it out, right?
No, this is it. This updates the balance.
Yeah.
We took it out here, and then we started re-implementing it here. Actually, you're right. I didn't.
Yeah.
You're right. I did not update the balances here. Lol.
Maybe it's a challenge for the next session. We'll let it be like that.
Yeah, we'll just finish it up real quick.
Then, if you want to be picky, when we check the balance against the 10 Juno, does it like take into account the current balance plus the amount that you are trying to deposit, or just the previous balance, right?
Oh, it takes you into, so notice we're loading the balances here.
So it doesn't take into account the new balance
right.
because you are depositing.
Oh, we also didn't check it right here. You're
Yeah.
right. So this is fucked up.
It's cool.
You got what it takes to be a smart contract developer. Yeah, so this is not fully working. And you're right. What if someone just deposited shit 10 Juno right off the bat? We would have not actually updated it here.
Yeah.
Yeah, this definitely needs a lot of work. We're gonna comment it out for now. But yeah, I'll try to like clean this up just a tiny bit, and then we'll push what we have. And then if y'all want to make pull requests against it, be my guest. Another thing that you can also do is implement like custom functionality using like, we're just gonna say game logic. So you could take the struct and implement it with all the logic for your game. So you might have a function, for example, that takes itself and maybe takes deposit amount, or just deposit, which might be oh my god, it's really yelling at me. But you could implement all your existing game logic on top of this metadata extension struct. That way, when we actually use it in the contract, we would just be like, instead of having to like do it all like in line, like we were doing it, we could just have something like a nice little helper do game logic function. And then you could have a separate code, you might even break this out into a little separate file, and then you could just have all the math and all the logic around updating like the weight and the power and like the luck, or any updating like the token URIs, things like that. You could do that all in like a kind of little mini library. And you could also test the mini library, and then that would make the code for like the deposit and burning like a lot easier to read. So yeah, there's lots. We could definitely refactor this a lot more, but I hope it gets across like the basic idea of how you can start building some custom NFT contracts for your various types of games. And then I'm hoping that after next session or whatever, or maybe after a couple more sessions, we might even have something that we could potentially deploy as a nice little fun like Juno game. And then maybe for everyone that helps out, we can start a DAO, and any like proceeds that are earned from the game can go to the Juno Game Devs DAO. So I don't know, figure it out. Definitely need more of an idea of what exactly the game is, but I really love this sort of like the piggy bank concept, is that each NFT like sort of gets like its own kind of like balance. Can be potentially pretty powerful for things like fighting games or whatever. You could also think about the metadata extension. Let's say you wanted to do, you know how like in Legend of Zelda, like the more you like use a weapon, like the more like its durability basically decreases. So you could have items like that would also maybe have like durability, for example, and you could have an execute like extension that like allows you to use that item, and then it might update something like in state about the durability of that item. And maybe if you use it one too many times, the NFT gets burned because you've used that sword too many times and it broke. But, so lots is possible, and I'm excited to keep building with you all, and thank you for listening. We've been going for 2 hours and 20 minutes. Wow, it's a long time to listen to me ramble and like code stuff without looking at Google. So yeah. Any last questions before we just wrap it up? I will put the code online somewhere and I will push it to GitHub and I'll paste the link in the dev lounge. All right, if there's no more questions, I think it's time to wrap it up. But this has been a lot of fun and I hope the recording worked okay. And then maybe we can edit this into a nicer kind of video. But thank you for coming to the first Code and Chill event. Actually, if you can do me a favor, and Rarma, are you still around?
Sir.
If we could collect the addresses, the Juno addresses of everyone who bothered to show up for this event, that would be awesome. Do you mind if we have some people like DM you their addresses?
Yeah, I have to change my DM settings, I think, but that's cool. Can do that.
Cool.
Keep them through.
All right, DM Rarma. If with your Juno address, thank you all for listening. I can't promise anything right now, but I think it's good to keep track of who's showing up to this stuff. And let's keep building and think about the kinds of games you want to make. Try to come to the next sessions with, I guess, a bit more ideas, and then let's try to build them together. And we'll keep also working on our whole streaming setup. I think an idea I had for next time is there's these kind of collaborative coding environments so that multiple people can like code on the same file. So we might try to like play around with that next time. Maybe try to get like Zeke or Reese to also come by. I think that could be really fun. But yeah, until next time, y'all have a great fucking day.